once again. Let us begin the class proper. I hope you enjoy it. So, module 1, Introduction to Artificial Intelligence. What is this AI technology? In definition, AI refers to computer systems designed to perform tasks that typically require human intelligence. These tasks include recognizing speech, understanding language, identifying patterns in data, solving problems, making predictions, and assisting in decision-making processes. Unlike traditional software systems that operate strictly on predefined rules, AI systems are designed to learn from data and improve their performance over time. This learning process allows AI systems to recognize patterns, adapt to new information, and automate complex processes. I mean, no matter how big the English might sound, the point remains that AI is simply computer, right? Computer that has found a way, right, to understand what human beings can understand when it comes to recognizing speech, when it comes to understanding languages, when it comes to identifying patterns, when it comes to identifying images, right? When it comes to solving problems. So whatever a human being can do, right, when it comes to thinking, an AI system can do the same thing. And the end result of thinking, or of making decisions, or of understanding the language, or recognizing the speech, is to make decisions, right, or predictions. So this artificial intelligence system can also make those predictions and also make those decisions for a human being, or like a human being can make. The difference is that the level of the decisions it can make is dependent on the number of data or the amount of data that has been fed. That is just the difference. You know, for human beings, you can, for instance, if you want to do a case as a lawyer, you have to go and research. You know, you get a textbook, you get the case books, you know, you look at case laws, you open Law Pavilion or whichever one that you use, you know, try to understand and get as much data as you can to soak it up so that by the time you are discussing your case in court, by the time you are drafting your process, I mean, you are going to be massacring anybody that comes close. That's the same thing with artificial intelligence. Without that data, without it being fed, without it being given a data, right, it can't actually exist. The difference when it now comes to applying machine learning to AI is that the thing learns by itself, right? So it improves over time. By learning, it improves over time. So the difference with these things happen. We're going to get to that in the future. So at its core, AI seeks to simulate aspects of human intelligence using computational models and algorithms. By analyzing large amounts of data, AI systems can identify correlations and insights that would be difficult for or impossible for humans to detect manually. One of the major use cases of AI is in the health sector, right? I saw a use case whereby they use artificial intelligence to determine people that have cancer, right? Using an X-ray system. So they use the X-ray, I mean, multiple times. They put a lot of X-ray data into the model, and then they trained it on those X-ray data. And they said it had over maybe 75% accuracy when it comes to prediction. But I think it was also used for people that have sprains and minor injuries as well. A lot of use cases when it comes to the health sector. I'm going to send you an article, right? More or less a book, because quite a lot of pages, right, on AI use cases, right? After the class, I'll add it to your materials for the class. Hope that is understood. So AI already plays a significant role in everyday life, as you all know. Like I said in the beginning, we all use ChatGPT. We all use Gemini. We all use Claude, right? We all use image generation tools, right? There's one called OpenArt. You know, when people use navigation applications like Google Maps, the system analyzes real-time traffic data and historical patterns to suggest fastest route. You know, people don't understand how that thing works. You know, don't understand how that thing works. And then the synchronization between your phones and your devices when it comes to analyzing the real-time traffic data is quite beautiful. Online platforms such as Netflix use AI algorithms to recommend movies and television shows based on user viewing habits. Voice assistants such as Siri and Alexa interpret spoken language and respond to user commands. Yes, we understand that there are risks involved when it comes to using these things, but we have to admit, right, it is unprecedented in the history of the world that we're going to have so much knowledge, right, in our fingertips, and we can have access to so much technology. You know, if I don't like to watch a particular thing, and the AI model has learned that I don't like to watch this kind of content, it's also giving me that kind of content, right? Thereby feeding me what I want to see. Ordinarily, that's a good thing, right? For instance, when it comes to you liking to watch news, or you liking to see documentaries, or you liking to see educational materials, right? It's another thing again when it comes to you liking to see maybe violence. That's another use case entirely. So why it has its good side, also has its bad side. I mean, I call it a double-edged sword. You know, Siri can do a lot of things. Alexa can do a lot of things. You know, although they said they're going to close down Siri very soon, we'll see. You know, so these systems illustrate what is known as narrow AI, the ones I talked about, the Google Maps and the Netflix, and Siri and Alexa, right? Although some form of natural language processing is also in Alexa, but I mean, basically, it's narrow AI, which refers to AI designed to perform specific tasks. While these systems can perform those tasks extremely well, they cannot operate outside the specific domains they were designed for. So basically, welcome to the future of the world. Like I said initially, AI relies on data. Without data that you have given it, it cannot function. If you give, if you want to train a particular AI model, let's say in the health sector, and you want to do maybe to solve HIV problems, for instance, you need to go and look for people that have HIV so you can know what they go through. You need to understand how they exist, what they use, the kind of drugs they give them. You need to talk to physicians. How do you find out about these people? When they come around, what are the symptoms you look out for? So by the time you create that AI model and it's giving out predictions when it comes to HIV, it has vast amount of data to get those information from. So it's like you, like I said, writing or trying to get a case and then reading a book to soak up enough data so you can go and fight in court. It's the same thing when it comes to artificial intelligence. You have to feed it. You have to feed it. On to the next one. Types of AI. Generally they say we have three types. The first one is the narrow intelligence, which is the one I mentioned earlier. So it has to do with task-specific AI systems. So this is what we want to do, right? So you train it just based on that particular thing you want to do. Right? It doesn't go beyond that particular one. It's just what you want it to do. The second one is general intelligence. We've not gotten to that one yet. Whatever it is that we are doing currently, including all the agentic AI, the narrow AI, the ChatGPTs, the Claudes, the OpenClaw, whatever I want to name it, they are all still within narrow intelligence. We've not gotten out of that yet. Then the third one, general intelligence, according to what I heard, according to what is there, they said that, because nobody has ever done it, they said that it can understand human beings, it can analyze emotions, right? And that it can actually make decisions based on emotions that it analyzes. I don't know how that's going to work, but I know that some people working on this emotional AI research currently in multiple countries in the world. So we'll see how that goes. And the third is artificial superintelligence. That one is one that will surpass our own human cognitive capacities. You don't even know what it is yet. You don't even got to that level yet. In this instance, we now have different categories, including reactive machine AI. So they're specific, they're narrow intelligence. So for instance, the IBM Deep Blue, the native recommendation we spoke about earlier, they are all specific. The one that has to do with email spamming, so the thing understands what email spam looks like. So when you get emails like that, they have the same format. If you always put them in your spam folder, that's artificial intelligence. It's as simple as that. So it's reactive, it is specific. The limited memory AI, they use past and current data to decide course of actions. So they can record events based on having a neural network, right? So they have a storage where they can where they keep information, right? So whenever you prompt it, it goes to go to that storage to go analyze whatever it has there, and it comes to give you the outcome. So basically, garbage in, garbage out. Then the theory of the mind, not yet, is part of that, or it is an actual general intelligence concept. We don't have that one yet. So your surroundings, it can understand everything that is going on. Basically, a machine that is alive, that is alive. Then the last one, which is self-aware, which is artificial superintelligence. Basically, we're talking about Skynet here, talking about Terminator, and they can think on their own. If they feel like we don't deserve to be here on Earth anymore because we have been eating too much plants or killing too many animals, they can take us out. That is the general discussion. I mean, it sounds silly, but when you understand that AI itself is a concept that emanated from people that play video games, then you get the concept, how these people think, So what do we need to achieve all of these things? How do we do artificial intelligence? What do we need to have in place to actually put this off? All of these beautiful things that I've mentioned so far. Number one, high-speed internet. It must not be the one that is in Nigeria here that, you have to struggle to get 20 MB per second, right? I'm talking very fast internet. Then devices. People have to have devices in that particular country. You have to have devices to actually take and undo the AI systems. You have to have a computer. You have to have good proper infrastructure when it comes to devices. Then you have to also optimize it for different devices as well. Then data storage and management. Yes, you need a data center. We're going to put data. Like I said, it relies on huge amount of data, vast amount of data when it comes to you getting these predictions accurately. The more data that you have, the more accurate your predictions will be. Right? It's as simple as that. So you have to keep that data somewhere. It has to be somewhere. So you need that storage. Also, you need management. How do you source for the data? How do you protect the data? How do you use data? Do you use the entire data, or do you find a way to synthesize it? Right? Do you use real-time data, or do you find a way to use predicted learning? Right? So those things are also calculated. The computational power, your particular country, what kind of power do they have when it comes to computational power? Right? How far can you go? Your computer speeds, your infrastructure, how fast are they? I saw one that NVIDIA just released when it comes to, they said, that it can do a lot of things and even take us to the super intelligence stage. That was NVIDIA, right? Because that's so much computational power. Then high quality data. What is the quality of data you are getting? If you're talking about HIV patients, for instance, are you going to go and meet the ones that go to, let's say, high-end hospitals, whereby if the AI system is giving you the recommendations of drugs, it's going to be giving you a drug of 200,000 naira? Or do you go to people who are in the low income threshold, whereby they are struggling to even afford antiretroviral drugs? So in that instance, AI will predict a drug that is, at least subpart whatever they're giving the UTIs. So high quality data, you need to get accurate data, you need to get good data, for you to create an AI system. Hope that is understood. If you have any questions at any point, just stop me and then ask your questions. Then we are in module 2, the history and evolution of artificial intelligence. I think I can just rush through this one without particularly reading it out for you. I'm going to share the document after the class. So you're going to have time to go over the document however you want it, but I will ensure that you get the gist of the entire thing. So yeah, history of artificial intelligence. AI itself started as a concept after the First World War. During the First World War, there was a guy, Alan Turing, the guy that created the Enigma machine. So the Germans were basically communicating in a different way using Morse codes and some machineries to communicate. And the British and the Americans and their allies could not find a way to decipher those codes. Thereby, they were getting decimated. What the Germans were doing was that they were sent a normal message that they know that the British will intercept and say that they're going to move towards a particular area or they're going to retreat from a particular area. So when the British get that message, they think, we can ambush them in this particular place. Not that they're just trying to lay an ambush. So they will now send that encrypted message to their own guys, to the other German, maybe the general on the battlefield, that this is what we have planned. The British will fall into your trap. The British don't know what they are. They think they have accurate data. They think they have intercepted their data. They think they spied on them, not knowing they have been baited. So the English will come and then they will get massacred. So it was becoming a big problem. So Britain had to announce to all the universities, the major ones in their country, for intellectuals, for scientists to come up with a solution to the problem. That's the one thing we are lacking in the country, in Nigeria. So to come up with a solution to the problem, then Alan Turing and some of his boys came up with the Enigma machine. It's not here because that's not the story. That's what it's all about. I'm just giving you like a background to it. So the Enigma machine it's secular, it has some secular things on it. So by the time the codes are being punched in, the thing keeps turning to decode it. And once they got the code, they were able to defeat Germany, with technology. So the same fellow in 1951 sat down again and thought about it. Is there a way that machines can think like human beings? Is there a way that machine can simulate human reasoning processes? Right? This is the guy. He's on the, if you're looking at my screen, the right-hand corner. The first guy on it, that's Alan Turing. Right? Then he created what they call the Turing test. So it's a method for determining whether a machine can exhibit intelligent behavior, right? That is indistinguishable from that of a human being. So they're trying to test it and test it and test it. They applied it to chess. Applied it to chess. They made some progress, but it didn't go as far as they wanted it to go. only for somebody amongst the team to remember that there was a guy in 1949 that created what they call the minimax algorithm. So they went back to the minimax algorithm that uses brute force. They applied it to the chess and the Turing test. And before you knew it, the chess was being played by the machine. So it just opened the possibilities of what AI can do to the world. I mean, how can chess be played by a machine? So the argument was, can this chess that's been played by a machine, can it beat a human being when it comes to intellect? Can it beat a human being when it comes to the high intellectual game of chess? So over the years, they kept on doing different tests. They were failing. Until 1997, when IBM they developed the Deep Blue system a few months back. But in 1997, the Deep Blue defeated Garry Kasparov, who was a national, I think, was a grandmaster of chess at that time. You know, it went viral. As a matter of fact, there's a movie about it. About Deep Blue and Kasparov. If you look at the right side of your screen, that is Deep Blue. That is the machine there, and the other fellow by the side is the grandmaster Garry Kasparov. You know, so that also opened the opportunity, the possibilities of AI. Keep in mind, that was 1997, right? So between 1951 and 1997, imagine what has been done. Imagine the innovation. Imagine the way they kept on working on that project until they found a way, right? Not like the way it is in some countries, whereby when projects begin, people tend to dump those projects. Right? You keep working on them until they work out. That is the purpose of human resilience, right? This event marked the first time a reigning world chess champion has been defeated by a computer under tournament conditions, right? And it was wonderful. Keep in mind, Deep Blue used what they call the minimax algorithm. Don't forget, and also using a brute force. So in 2016, Google's AI research lab, they call them the DeepMind, very intelligent guys. That's what they call the AlphaGo. So the Go is, I think, it's a Chinese game, right? It's very technical too, even more technical than chess. So they said that if an AI system can defeat a human being that plays Go, then that is the height of intelligence of an AI system. Keep in mind that applying these things to video games, to games and things along that line. Then before you knew it, AlphaGo was able to defeat Lee Sedol, right? Who was a champion in Go. Right? It was so wonderful at that particular time, 2016, when we saw that this thing was able to achieve it. To give you a background of what I mean by my elder brother has a PhD in artificial intelligence, so he teaches it. We've been working on AI systems. He was in university, so I learned from him. Watching him do it, and because he read computer science, so watching him do it, he and his friends were always deploying AI systems, even at that time. So we have a form of background on what it is because of the experience that we've gotten from it. So AlphaGo use what they call the deep learning and reinforcement learning. We'll get to that much later. But deep learning works with neural networks. So what happens is this: a neural network was created in 1949, around that period. So what happens is that the neural network is created like a human brain, right? So when you stack it on top of each other in multiple stacks, right, it becomes deep learning because the information is vast, right? And it works like the human brain, so the thing can think. As a matter of fact, I think some people don't even understand when it becomes when you layer it too much, you can't even understand how it works anymore. That's where you now come to discussions of responsible AI. You have to understand what you are doing. Don't give this thing too much power. Don't feed too much information. Don't put too much neural networks. Don't mess us up. So those are the things when it comes to artificial intelligence. I didn't put this, but let me give you a wrap up of the history. So the way we got to this new AI dispensation that we are currently is this. Around 2016, when the DeepMind guys were working on this AlphaGo, OpenAI, of course they had data too, but working on different AI systems, only for them to figure out what they call the PPP, right? An optimization technique, and they applied it to the current data set that they had. And for some reason, the thing was giving them prompts and was responding, right? And they thought about it. This is a gold mine. And before you knew it, 2019, it went out there. 2020, by the time 2021, ChatGPT was everywhere. So from ChatGPT, if you notice, ChatGPT came first, then before you knew it, Gemini came after, because they were working on the same project, both OpenAI and Google DeepMind on the same project at that particular time. So they were able to release both products back to back. So people have worked over time to improve AI. People have worked over time to benefit from what it can give to the world. It is now time for people like us who are in other countries, but benefit from intelligence from other places too, other countries. We have to find a way to benefit properly from artificial intelligence. We must use that technology that we've gotten from all these people who have spent their time since 1949, to create this technology, to ensure that it is used properly for our country. It is a tool that we must use to develop our country by all means. And I hope that most of us in this class actually believe that as well. So if you have any questions, please, of course, ask me. How can we use this technology in our country? Number one, we have insecurity and banditry. Right? Ayo, can you hear me? Can you guys see me? Let me confirm that before I proceed.
I can hear you. Sir.
Beautiful. Yeah, can you see me though? Can you see me?
Yes.
All right.
I can see you. I'm not
no,
sure.
I cannot see you now.
Probably the network. You catch up. So
okay.
The first thing, insecurity and banditry, right? How can we leverage AI systems to ensure that people are saved, ensure that people don't get killed, to ensure that people don't get displaced from their houses, right? By getting data. How do they do these things? What are the routes the bandits pass? Right? What are the times that what are the times that they come out, most especially? Because they have reconnaissance. So around what period they come out? Around what period they operate? What is their operational model like? What do you have to do before they operate? Obviously, if you're paying for a battle, right, we have to source for materials. We're talking buying fuel, buying petrol. So when there's a high increase in fuel purchase in a particular zone, you should know something is coming in that regard, right? When there's a high purchase of food materials like bread, like sardines, like Coke, right? And you don't know who these people are, and people can report these things. You know that something is definitely coming up, right? So we need to get this kind of data. Another thing we can also do when it comes to using AI for insecurity and banditry is to use what we call the computer vision. So we analyze the images of all the bandits that we believe to see, right? On the internet, in Nigeria, maybe just posters, whoever has spoken to us, whoever the intelligence people have their data with them. We get all these things, put them in an AI model, right? Anywhere they are in the country, once they get flagged in that particular place by our AI model that we have, by our surveillance system that we are working on, right? We get that location immediately. It gets pinged. When it gets pinged, it can be sent to the military, and they can make an airstrike in that particular zone. That is the same style that Israel is using right now in Iran, right? They have surveilled all the generals in Iran. So by the time they see this particular, when the camera picks up the general walking on the streets or entering a particular house or in a particular car, it's going to ping them. When it pings them, they send the weapon. So in that instance, it actually saves a lot of stress when it comes to you going to go and look for them, trying to know where they are per time, getting on-field assets, etc. Right? And when it comes to us helping their IDPs, we can get their data, know who they are, where did they go to after they get displaced, right? What are their chances? What do they need most? When we talk about giving them menstrual pads for the women, talking about giving food to the children, we can use data to make these decisions. We can use AI to move our country forward. We can solve these problems. When it comes to healthcare, I already made mention of the HIV use case, right? Which is something that we're working on in the office, right? We'll see how it goes. Because, like I said, you need a lot of data. I mean, getting health data is quite stressful. So that one is one. It's a new concept anyway that we're just developing. So it's not as if we got to that stage yet. But it can be used for a lot of things when it comes to health, as you know. There's a use case in, pardon me, there's a use case in I think in England. Was it England? I think so. Right? Whereby they integrated AI systems into medical reports. Right? So for instance, when it comes to you getting an ambulance, right? If you are black, according to what I heard, if you are black, the AI system is biased towards black people. I also saw one in Netherlands. I saw that one. The actual implementation on YouTube, right? And the AI system, the use case is to actually give people money when it comes to social services, giving low-income households money. But this AI system was not giving Hispanic and Black people their social services money because, according to the data it has been fed, the majority of the Black people and the Hispanic guys are criminals. Imagine that. People getting deprived of what they should ordinarily benefit from the government because an AI system deems you a criminal. But we get to the risk much later. We're just talking about what it can be used for now when it comes to social services. So yes, in Nigeria, when it comes to us doing disbursements, when it comes to us getting for our people, right? When it comes to what the majority of people want, doing surveys, yeah, we can use artificial intelligence. When it comes to engineering, it can be done as well. I saw the use case of in engineering in China, right? They have a combustion system now that is so powerful. They use artificial intelligence to figure it out. They will make a mistake. The AI will make a wrong calculation. They will improve it by giving you more data, right? By giving you more data, and they tell you to predict another calculation. They will predict it, and then before you know, they will implement it. Now they have that combustion system ahead of the entire world. So that's what can be used for when it comes to engineering. For weapon systems, you mentioned that already. For economy, obviously, economy is a concept that is based on thought, right? Whatever people think is what they implement. If you think that the economy of the country should go in this particular way, maybe you want to be a capitalist or you want to be a communist, you can actually dictate that, right? It must not be, whatever anybody calls it. So when it comes to economy, we can put data in this particular thing. We can tell you to predict what we should do when it comes to our economy. And if it have a proper data sets, it can give us good answers, right? Then when it comes to infrastructure and of course education. So AI has a lot of use cases. And for a country like Nigeria, I mean, these are, in my own way, what I think that we can use artificial intelligence for. Obviously, as time goes on, we're going to be getting more information, we're going to be knowing more things, we're going to be getting exposed. The more exposure you have, the better for you when it comes to making decisions. So by the time we move ahead in data science in the world, and even in Nigeria, and we also practice these things, before you know it,